Welcome back, folks. So the next part of our big race problem is asking us, when and where does Leslie catch up to Evie? Now, first off, we should just confirm that this actually makes sense and that Leslie actually will catch up to Evie. So if we go back to what we were talking about in the previous video, remember Leslie starts off at the origin, at the starting line, no head start, and goes 2 meters per second. Kristen gets a head start and goes of 8 meters, and it goes 2 meters every 5 seconds. And Evie gets a 6 meter head start and then goes at a speed of 5 meters every 4 seconds. Okay, now in this particular question, we're curious about Evie and Leslie. Now notice, Leslie starts off behind, of course, but she's going faster. And so it makes sense then at some point, she's going to catch up to Evie. Okay, well, where would I see that on the graph? And that's the whole point of this, is that we could actually answer this question with a graph, a table, or an equation. And so on the graph, well, let's think first about what catching up to means. So if I'm using my hands, here's Leslie. Leslie's behind, Leslie's back here. And Evie has a little bit of a head start. And so what's happening is that as time goes on, let's do it this way. Leslie's down here, Evie's up here. Leslie goes a lot faster, and so eventually, here's Evie going up slowly, but Leslie going faster. At some point, they catch up. So when they catch up, what is true? Well, when they catch up, this means they're at the same distance, because they're right next to each other, same distance, but also at the same time. And the same time part is pretty important, because at some point they're both going to cross 10 meters, but if they're not there at the same time, then Leslie hasn't actually caught up to her yet. So this is where we're getting at, same distance and same time. Now in this case, remember that the distance that is being recorded with the y coordinate, and the time is the x coordinate. And so if they're at the same x and y coordinate, that really means we're looking at where they cross. Look where the lines cross or intersect. I want to take a second just to emphasize here. The verb that you're looking for is intersect, not intercept. Intercept is a noun, sorry. I was struggling for the term. It's a noun, an intercept, where the graph crosses the x-axis or the y-axis. But if we're looking at just any two lines where they cross, generally, we call that where they intersect. The actual point, we call it the intersection. Okay, so in this case, on the graph, I'll erase it, on the graph, we will look where they cross, and that would be right here. So it looks like a coordinate of 8, 16 there. They cross at 8 seconds, so I'm going to emphasize that, 8 seconds, 16 meters. So they're going to, after 8 seconds, they're both going to be at 16 meters, and then Leslie's going to pull ahead. All right. Now, here's a problem with a graph, and the graph is helpful usually because we know a good amount about linear functions and how to graph them. But sometimes, your ruler, you can't get your ruler perfectly, or you don't have nice clean lattice points to draw your lines through. And so it's not always perfect to just trust your graph. And so what we can do then is, now that we actually have the equations of these lines, we can actually confirm this. So, and it's nice here with function notation. Now again, if they're at the same place at the same time, to actually confirm our answer, this would mean that at 8 seconds, or after 8 seconds, I'll say. Well, no, it would be at 8 seconds, Leslie has gone, how far? Well, she will have gone 16 meters, assuming that we're correct. And so has Evie. Now here's the thing, what's nice is that I can actually use my function notation here, kind of tying everything back, to kind of write this out. what we're saying is that if this is true, then we would have to say that L of 8, because 8 is our input, remember? Inputting 8 seconds equals 16. And likewise, if it's true for EV, then also E of 8 would have to equal 16. So let's double check. Remember, L of x is 2x. And so if I plug in 8, I think we can see L of 8 equals 2 times 8, which is 16, again, 16 meters. Check. And then for EV, E of 8, that'd be 5/4 times 8, plus 6. Plus 6, sorry about that. Plus 6. And now we can clean this up. Let's see, that would be 40/4, which is 10. And so 10 plus 6 equals 16. So indeed, actually, this tells us that Leslie and Evie have gone. Now I'm just kind of repeating that for emphasis. Have gone 16 meters in 8 seconds. And that's kind of answering this question. When and where? When, 8 seconds, where, 16 meters along the race.